Alright, hey everyone, welcome to the Winter Limnology Network sampling protocol in the winter. We're here on Long Lake in the Twin Cities of Minnesota. As you can see, there's not much snow, but there's a lot of ice. So this is January 7th, and we're going to take you through our winter sampling protocol. You should have gotten a standard field sheet like the one Anthony has here, and we're going to start with some site information. So you're going to record your PI or your group name, the lake name, Long Lake. We're going to get the date. Time in is 10:30, and we will record our site coordinates. So Anthony, it's 44.98762 minus 93562087.
2087.
Okay, we'll record site depth in a second, but in the meantime, we'll record some weather conditions. So mostly cloudy. It's about -7 degrees Celsius. There's a light wind from the north. Yeah, it's good. Site access in general, site observations. So we access it from the boat launch site. There is no snow. We walked across the ice. Yeah, no snow on the ice. As you can see, there are several people ice fishing around us. Yeah. Nice. We're gonna make a few holes for different purposes. Our first hole is to just get site depth, and we're also gonna do our CTD profile through this hole. Because the CTD is going to impact the bottom and stir up the bottom, and we're collecting near bottom water, we're going to work in different holes. Now we're also going to make a separate hole for light and ice quality observations. Generally you could use the same hole for that, but for a reason I'll explain in a bit, it's actually easier to have a few separate holes. Okay, so we have a handheld depth finder that we're going to use to measure site depth. 9.3 meters. We can also measure the ice thickness here. One way to do it is using a chisel, for example. So we can catch the edge of the chisel on the bottom of the ice and measure the ice thickness. It happens to be about 31 centimeters, but we're actually going to do another way of measuring ice thickness in a bit. We're actually going to get an ice core and record observation about layering and things like that. Okay, so next we're going to do a CTD profile. We have an in situ Aquatrol 600 that we use. So I'm going to put it in the hole we made, give it a couple, maybe a minute to equilibrate the temperature of the water, and then we're going to do a profile. As you probably know, electronics like CTDs and other battery operated devices don't do very well in the cold. So what we typically do is we have a cooler where we keep all our electronics with a hot water bottle to get to the site. This prevents batteries from dying, and also some sensors like pH sensors, for example, are quite sensitive to freezing. So we typically keep them in this warm cooler for transport. Okay, so the temperature sensor is probably equilibrated, and now we're going to do a slow profile, sort of at approximately this speed, all the way to the bottom. Okay, so the next thing we're going to do is collect a light profile through the ice, and if there was snow, we'll do it through the snow as well. Our goal here is to create a hole in the ice to fit our Lycor light meter through without disturbing the surface of the ice and snow. So what we're going to do is we're going to get a light profile through the ice over here, and we're basically going to use the sled to try and prevent slushing and essentially disturbance to the surface of the ice. Now, if you notice in the profile, we're asking you to do a profile with snow and without snow. Again, because there is no snow here, we're going to explain what we mean with snow and without snow. but we're just going to do the profile without snow. But again, the first step is to create a hole for your light meter, minimizing disturbance to the surface. The way, again, like I said, we'll do is we'll use this sled as sort of a cover, and we're going to keep the ice, if there is snow, undisturbed on the south side of the hole, because that's the direction the sun is shining here. So as you can see, mostly worked. The ice is pretty much undisturbed. This is not quite large enough for us to fit our Lycor light meter, so we're actually going to make the hole a little bit bigger using a saw. And while we do that, we're going to be able to actually get a little chunk of the ice that we'll remove to record any observations about ice quality, and also get a nice precise measurement of ice thickness, and take a photograph of the ice. You'll notice in your field sheet we asked you to take a few photographs of the ice, so hopefully you have already taken a photograph sort of of the general site, and then take a few photos of sort of what the ice looks like, give us an idea, and then next you'll be able to take a photograph of the actual ice core itself. So we have a nice long ice saw. It works quite well as long as the ice is not very thick. Nice. So as you can see, a nice layer of clear black ice. We're gonna get our meter stick. Interesting. I don't know if you can see, there's an interesting greenish inclusion in the ice here. Kind of neat. Okay. So gonna measure the ice thickness. 30. Looks like pretty much 31 centimeters. 31 centimeters. And we're going to get a photograph. Anthony, do you mind taking a photo? It's nice to have the field sheet right next to it, so it's easy for us to tell where it's from and all the other information. So let's see, 0 should be at the surface. It's the top of the ice. Here's the bottom. And Anthony will get a photograph showing again the clarity of the ice and any layering that might be apparent. Okay, so we're ready to do our light profile. So we have a LI 250 light meter connected to an LI92A flat quantum light sensor, and what we're going to do is make a few measurements. So our first measurement is going to be in the air, and we have an averaging function on our light meter which we use for getting average values. So we're just going to hold it flat, making sure we're not shading it, and collect air measurement.
211.5.
Okay, next we're going to collect what we're calling an albedo measurement, which is basically an attempt to measure reflection of the surface of the snow and ice. So assuming if you do have snow, you're going to do it over the snow. Because we have no snow at all, we're going to do it off the ice. So the idea is to just flip the sensor upside down and face the sensor towards the ice or snow.
19.28.
Great. So if this was sort of a normal time of year, there would be snow on the ice, and we do our first profile with snow-covered ice. Because there is no snow, we're going to do it like this. So our first measurement underwater is going to be right under the surface of the ice. So what we're going to do is insert this under the ice and press the sensor to the very bottom of the ice, collecting an under ice measurement.
99.22.
Okay, great. So now we're going to collect measurements every half meter, starting from the upper surface of the ice. So our rope is, or cable is metered in half-meter intervals, and what we do is we cover the hole in the ice with a sled or something else dark to make sure we're not we don't have too much light leakage. So here is our half-meter measurement from the upper surface of the ice.
62.93.
Okay, here's 1 meter. And we're going to do this in half-meter intervals to 3-meter depth. So again, if there was snow on the ice, at the end of the water column profile, it would come back up and then clear the snow off of this area of ice and collect another measurement through the ice without snow this time. And what then we would get is a measurement of light attenuation through snow and ice, and attenuation through just ice, and then attenuation through the water column, and we can sort of separate these things together, apart.
43.85.
Okay. 1.5 meters. So for snow and ice conditions, you know, if there was snow cover, we'd estimate % snow cover. Here it's 0% snow cover, so 0%. If there was snow, we'd measure snow depth in 5 locations, sort of, you know, using a meter stick, and, you know, go and choose 5 random locations or hazard locations around the site and measure snow depth and get an average for that. Notice we recorded ice thickness here. Again, if there was snow, you would write some snow observations, perhaps something like, you know, a crust of icy crust on top of the snow, or a fluffy light snow all the way through, or whatever. And then you have a spot for ice observation. So here I'm going to sort of write, you know, clear black ice, you know, some cracks, and then I think I noticed this layer of green, maybe looks like algae or something like this, frozen into the ice. So I'm going to make a little note of that. And this layer is about something like 24 centimeters down. So at 24 centimeter depth, greenish layer, approximately 2 centimeter thick. Yeah, something like this. Okay, our next steps are to get water samples, zooplankton samples, and we're also going to get Secchi depth. Fortunately, we can do all those things from inside the tent, so we're going to make a hole in the tent and collect those observations. Our zooplankton nets are about 30 centimeters in diameter, so we need a slightly larger hole than we can make with a single auger. There's a couple of ways we can do this. One way is to make 3 holes in a clover sort of leaf pattern with the auger, but because we have this saw, we're just going to make 1 hole and then expand it using the saw to make a hole that's big enough for us to put our gear through. So helps to clear the slush from the hole, especially for when you're doing zooplankton tows, because otherwise the slush is going to clog up your net. You've probably all seen slushers like this. They're kind of useless. What we prefer to do is just a collapsible pasta strainer. They don't take up a lot of space and they work much better. I'm just going to use this to pull out this chunk of ice. Okay, so next we're going to get Secchi depth, and then we're going to collect our water samples. Our oceanographic style giant Secchi disc. Kind of neat because in the summer this lake's Secchi depth is approximately a meter or so, but looks like it's going to be, I don't know, maybe 4 or 5 meters now in the winter. About 7.1 meters for Secchi depth. Yeah, again, 7 times more than in the summer. Pretty cool. Okay, so we're ready to get our water sample. So we're collecting 8 liters from each depth, and we're collecting from 3 different depths. So we're collecting right under the ice in the water column mid depth, which is 4.5 meters for us here, and 1 meter above the lake bottom. So it's about 8.2 meters for us. It's important not to hit the bottom with the Van Doren because unlike in the summer, moving to a different undisturbed spot is kind of a pain in the butt, and the water column will take a while to get settled if you disturb it, so we try to be quite careful. So we're going to get our subsurface, sub-ice measurement. Where's our top? You can see that things are sort of frozen. Again, for that reason, we also usually try to keep our Van Doren and zooplankton nets in our warm cooler with a bottle of warm water. We have a heater, so we can also put it in front of the heater to carefully thaw it if it's really frozen. We'll be back once we sort these technical difficulties out. Okay, so we're gonna get our first sample right under the bottom of the ice. Okay, a handy funnel here, and the funnel too. For the funnel, and we're going to do a triple rinse of all the containers with a little bit of the water from the site. We have a lid somewhere, I'm sure. Oh, there it is. And we do the same thing with the rest of the bottles from this depth, and then move on to our mid depth, and then do our deepest site. And it's kind of neat because you can see a ton, maybe you can't see it here, but there's a ton of big, happy looking Daphnia and big copepods swimming in there. But we'll get a closer look at what's in here once we collect our zooplankton too. Okay, so we finished doing our water. We recorded the volume that we collected, 8 liter, and the depths that we collected our samples from. You know, if there are any particular notes that you want to make, there's a space to make any water sample notes. I don't know, like for example, bottom water smells weird or something like this, which often happens in this lake in the summer. So our next step is to do zooplankton net tows. We have 2 nets, both 30 centimeters in diameter, an 80 micron mesh net and a 35 micron mesh net. We're going to collect duplicate tows with each of these nets, starting with the 80 micron and then switching over to the 35 micron net. We have some bottles, which you will also have for these samples. So again, we do duplicates. Depending on the density of zooplankton, you will do potentially more than 1 replica tow for each of the duplicates. But you know, even looking here, I can see that there's a ton of zooplankton, so 1 replica is going to be plenty for our quantitative sample. Once we do the quantitative tow samples, we're going to do a collection for fatty acid and stable isotope analysis, which we'll show you in a second. Basically, we're doing our tows from surface to 1 meter above the lake bottom, using a moderate tow speed of like 5 seconds per meter or something like this. So show you what that looks like. Second. Okay. First, to make sure this is pinched. This is right. There you go. And because we're going to be doing quite a few tows from this depth, just so we don't have to count every time, what we find helpful is just tying a little loop at 8 meters, so now we don't have to think or count next time we're doing this. All the way to 8. Okay, and then we do a slow tow on the way up. Okay, so the 80 micron mesh tow will go into the larger bottle. It says 80 micron on it. First sample. There's a little bit of stuff all the way along the sides. It's from the bottom. Maybe with a third rinse. So much stuff here. Let's see the bottom here. So yeah, a single tow is definitely going to be enough. You can see that it's a very dense sample. I hope you can see that. Yeah, and what we'll do is top the bottle up to about 80% with say surface water using the other bottle, and then when we get a chance sometime soon in the next hour or so, we're going to preserve the sample with Lugol's how much?
Oh, 10
mils 10 mils of Lugol for this jar, and then 5 mils of Lugol's for the smaller jar for the 35 micron mesh. So we're going to do another replicate with the 80 micron mesh now, and then we're going to switch nets to the finer net and again do a single tow with each one of the 35 micron tows into the smaller bottles. So we finished collecting our quantitative zooplankton samples. So we have our duplicates of the 80 micron mesh tows in the larger bottles, duplicates of the 35 micron mesh tows. So we're going to record some information about this. So net diameter, 30 centimeters for both, mesh size, 80 and 35. Again, there's a ton of zooplankton here, so we didn't need to do combined tows, so each one has just one replicate, and we went to 8 meters, so the tow depths were 0 to 8. Yes, 0 to 8, 0 to 8, 0 to 8, and because we know the tow depth, the net diameter, we can figure out the volume that the net collected. If there are any particular notes that you want to make about your quantitative net zooplankton tows, you can do that here. Nothing really to note. So really the last thing that we're going to do is collect duplicate tows for stable isotope and fatty acid analysis in zooplankton. So we're going to use our 80 micron mesh for this, and we're going to collect it in duplicate into these larger bottles. The reason we collect it into these 1 liter bottles is to allow an opportunity for dead material or phytoplankton to sediment. And here, instead of collecting 1 or even 2 zooplankton tows, we're going to collect a few of them. How many you're going to have to collect will depend a lot on the zooplankton density in your lake, but the idea is to get a large sample for getting fatty acid content results. So we'll show you what we're sort of aiming for after we've done a couple tows. And you know, in some lakes we have to do like 10 tows. In this lake it's probably going to be maybe 2 or 3 tows for each duplicate to get a really large sample. So we'll show you in a few minutes what we've gotten. Okay, so this is 3 tows. Again, we're not trying to be super quantitative. The goal again is to get just a whole bunch of zooplankton biomass that we can use for analysis later. So that's, you probably don't need quite as much. You could probably get away with about half this density, but you know, make sure you have a dense sample. And again, what we're going to do is let this sit upright and let all the inorganic material and like detritus and hopefully some of the phytoplankton sediment to the bottom, and then in the lab we're going to carefully decant the zooplankton, trying to get a clean zooplankton sample. So we're going to do it once more for our second replicate, and that's pretty much it. What we're going to do is just quickly write the tow depths, which again was 0 to 8 meters here, and the number of combined tows for each of these. Again, we're not being quantitative necessarily, we just want to get a lot of zooplankton here. And again, And for us here, probably could have gotten away with just 2 tows. For really oligotrophic, mountain cold lakes or Arctic lakes, you might have to do like 10 tows or something like this to get enough material. And in some cases, we just can't get enough material. So if you do like 10 tows and there's nothing in the sample,